Okay, how do we protect the security of messages we send? Right. It's a really important issue in the technology age. We're sending information electronically all the time. So we want to make sure that we can send it securely. So think about all the times that you send information that you hope no one else can read, right? Text messaging, emails, online shopping. What doesn't? So it's not an option to prevent your messages from being intercepted because we're sending them over public lines, networks that are owned by other companies. We don't own them, so we really don't have any mechanism to prevent someone else from getting them, right? But what we can do is keep people from being able to read the messages that they intercept. So we try to disguise them so that the message will only make sense for the intended recipient. And that process is called encryption. So whenever we encrypt a message, it's vital that we do it systematically. Both you and the person you're sending it to have to agree on a secret system. Okay, so many systems are based on a keyword or a phrase that's known only to the people exchanging information. So cryptography is the study of processes by which information is disguised so that unintended recipients can't understand it. A cipher is just the word that we use for a rule that disguises a message. And there are many different ciphers. We're going to learn a few in today and then a couple more in the next few classes. So remember, encryption is the process of disguising the message, and decryption is the reverse process of figuring out what the message says once you receive it in disguised. Okay, so we want ciphers that are simple enough to use regularly, so that it's not really difficult to disguise the message, but complex enough so that it's not easily decrypted by someone who doesn't know the rule. And it's really vital that the cipher be a reversible rule. Otherwise, the message can't be undisguised, and there's no point, right? If you send it to someone and they can't figure out what it says, then there's no point. So one of the simplest and oldest ciphers is called the Caesar cipher. It was named after Julius Caesar, who used it to communicate with his generals. You take the letters of your message and change them according to this rule. You take each letter in the message, replace it by the letter that's 3 places later in the alphabet. So you replace A's with D's and B's with E's and C's with F's, etc. Every letter gets replaced with the letter that's 3 later. What do you think happens when you get to the end of the alphabet? Start over. Yep, it becomes A, B, C. X goes to A, Y goes to B, and Z becomes C. All right, so here's an example. If I want to encode the message attack at daybreak, A becomes D, right? And then T, U, V, W, 3 letters later becomes W. You replace each letter with the 1, 3 after it. And we end up with this message that looks like junk, right? D, W, W, D, F, N, D, etc. We typically omit spaces and other punctuation when you encode a message. And because knowing the lengths of the words in the message can help the enemy figure out what letter means what, right? Because single words that are a single letter are really easy. They have to be either A or I. At is easy. 2-letter words are easy. So what we do is once we encrypt it, we put it in little 4-letter blocks, right? So they can't tell the lengths of the words. So we have little 4-letter blocks. And the block length doesn't really matter. You could do blocks of 5 or 6. It's just so that you just do it so that you can't tell the length of the actual words.
various lengths within a, or have to stick to the same block?
I think it makes sense to stick to the same, but it doesn't really matter. Yeah.
Even though we already did a proposal, like write a whole letter in your own sentence.
Sure. That would be a good project idea. Write a paper or something in encrypted. Yeah, I like it. Yeah, well, you could also make an Excel spreadsheet where you could type what you want to say and have Excel automatically encrypt it. And then if you hand in the electronic file, then I can see what it does. That would be a cool project. So to decode a message using the Caesar cipher, you simply go backwards 3 steps in the alphabet. So to get from D to the letter it was, you go backwards 3 steps. You go C, B, A, right? So you go backwards. And you might have to wrap around back to the end of the alphabet again, right? So if you have an A that you have to decrypt, it would be Z, Y, X, right? So here's another example. Here's a message that I encoded using the Caesar cipher. Try to decode it. What does it say? Okay, I just paused it when I had you decrypt the thing. So our new method is the Bifid cipher. We use the Polybius square. You can fill in the alphabet normal, or you can fill it in based on a keyword. Okay. Confidential is misspelled. It's misspelled because you don't ever want to repeat a letter. So once it's in the box, once it's in the square, you don't ever repeat it. So we put in confidential, fill in the rest of the letters of the alphabet without duplicating a letter. Now I'm going to use my square to encode a short message. I'm going to encode retreat. So the Bifid cipher requires messages to have an even number of letters. You'll see why in a minute. Retreat has only 7 letters, so I'm going to add a dummy letter to the end. I'll just put an X or a Q, something that can't easily be confused with part of the message. Okay, so I'm just going to use an X. So I wrote out retreat X, right, so that I'll have an even number of letters. Then I look up each letter of the message in the table, and you always go row column. So I'm going to find R in the table. It's right here. And it's in row 4, column 3. So I write that down, 4, 3. Then I look up E in the table, and it's in row 2, column 2. And T is in row 2, column 3. R is 4, 3. 2, 2. A is 2, 4. T is 2, 3. And X is 5, 3. Okay, so the next thing I do is I'm going to take the column list and move it so that it's one long row across. So my message is now going to be 4, 2, 2, 4, 2, 2, 2, 5. And then I'm going to write out the second row next to it. So it's going to be 3, 2, 3, 3, 2, 4, 3, 3. So you write it all out across. Yeah. Then you pair up things that are next to each other. This is why you have to have an even number of letters, so that when you do the pairing up, when you go across, that everything has a pair. It has to be an even number. Then you look up these guys in your Polybius square, row column. So when I look up 4, 2, row column 4, 2, I get a Q. Nope, because I'm reading across now. 4, 2, 2. Then when I look up 2-4, 2-4, I get an A. 2-2, E. 2-5, L. 3-2 is G.
5 is W.
2-5 is L.
Should be W on the paper.
Nope. You're looking at 5-2. You have to go row column.
They have it.
2-5. Oh, I have it wrong. Yep.
You
It's
have it
L.
wrong or
Yeah.
this is wrong?
This is wrong. Okay, so 3-3 is H. 2-4 is A. And 3-3 is H. So this is my encrypted message. Doesn't make any sense at all. Looks like junk. That's the idea.
Look like junk with the number. That's
We-
not code right there.
Right. So there's my encrypted message. Okay, so just to review, write out the word, look up each letter, and write its row column vertically. Row column.
Now, can you use any word in the first few lines, or does it always have to be confidential?
You can use any word, as long as the person receiving the message knows the keyword.
Okay, so
Yeah.
it'll still come out like with the numbers and stuff.
Yes. Yep. I mean, it would be different numbers, but it will still work. Okay. So we looked up each letter, wrote out its row column vertically. Then you move them next to each other. Okay. So I'm going to take the bottom row and just move it up next to the top row, so it's one long row of letters. And you do the groups of 2. Now you read them in groups of 2 going across, and look up the letters in the square. So 4-2 is Q, 2-4 is A, 2-2 is E, and 2-5 is L, and I screwed that up apparently in the notes. It says W, it should be L.
That's clear.
Yeah. That's actually an L. So our encoded message is QAELGHAH. Bunch of apparent nonsense. To decode the message, reverse the process. You have to look up each letter in the Polybius square, like each letter from the nonsensical seeming message. Look it up in the square, write down the row and the column, but write them from left to right. Okay. Then you split the message in half, take the right half and put it under the left half, and then read them top to bottom and look up the letters that way.
Wait, do you put the column on the top and the row on the bottom?
Nope.
Okay, so we're going.
So here's a message, some junk that was encoded using the Bifid cipher. The Polybius square was based on the keyword Schwarzenegger.
We have our target.
So if we want to decode the message, first we have to build a square. Well, first we have to make sure that the message has an even number of letters. It does. Okay. So then we create our Polybius square, and we fill in the word Schwarzenegger without ever repeating a letter, right? So once we already have the letter in there, you don't write it down again. So I start out writing Schwarzenegger, right? But after I do the N, the only letter I haven't used yet is the G. Then you fill in the rest of the alphabet. Any letter that wasn't used in Schwarzenegger, you put in the grid in alphabetical order. Okay, so here's my message. It was SAW, ABT, BKK, STV, LAAA. So I look up each letter in the square and write down its row column, okay, horizontally, because I'm going backwards from before, working backwards. So I look up S. Here's S, it's 1-1. Write down a 1-1. We look up A, it's 1-5. So I put down 1-5. Okay, then I'm going to break the message in half. So the halfway point of this message would be between the K's, right? And I'm going to take the right half, all of this, and write it underneath the first half. So I get 3, 5, 1, 1, 5, 1, 5, 3, 4, 1, 1, 5, 1, 5, 1, 5. Then you read down. You read vertically, row, column. So my first one is 1, 3. Right? So when I look up 1, 3, row 1, column 3, I get H. Then I have 1, 5. Look up 1, 5, and I get A. Then 1, 1, S. 5, 1 is T. 1, 4 is, I'm sorry, 1, 5. 1, 5 is A. 4, 1 is L. Yeah, it's hasta la vista, baby. So just to review what we did, right, to decode the Bifid, we wrote down the row column all horizontally, break it in half, move the right half under the left half, then read them down vertically, row column vertically. And you get hasta la vista, baby. So, no. So after today, you should be able to encode and decode messages that use substitution ciphers and the Bifid cipher, and your homework is this worksheet. Yeah, I don't think so. Thank you.